All right, welcome back, everybody. So today we're going to be doing notes 2.4, graphing quadratics in intercept form. Now, the other day we were talking about factoring, and when it comes to factoring, we always want to make sure that we're looking for a GCF when we factor. And so we're going to do one more just as a practice. So when we're looking at this problem here, we see a 3x squared, a negative 12x, and a minus 15. When we think about what's the number that divides all of them, we can see that the number 3 would divide into the 3, the 12, and the 15. So yes, that would be my GCF. So this is what I'm thinking in my head. I'm thinking about division. But when you're factoring, you have to make sure that you bring the number out to the front. And in parentheses, we're going to leave what I like to call the leftovers, which is what we get after we divide everybody by 3. 3 divided by 3 is, of course, 1x squared. Negative 12 divided by 3 is negative 4 with an x. And negative 15 divided by 3 is negative 5. So now we're not done factoring. Remember, the next step is I write down my 3 because that's officially part of my answer when I factor. But then I need to break this part up. The x squared minus 4x minus 5 is what I need to break up. And the nicest thing is we have two x's, right? X squared. So we write 1 and 1. There's no number in front. So now all I'm thinking about is this. I have to think about what multiplies to give me a negative 5. And of course, if it's a negative, that means one number has to be a positive, the other one has to be a negative. And now, whatever numbers I pick for my 5, which if you think about it, the only multiples are 1 and 5, the combination of these two, one positive, one negative, needs to result in a negative 4. So if we think about it, right? If I have a 1x and I have a 5x, but I want to end up with a negative 4, then my 5 should be the negative. So now I know to put my negative 5 in here, and then this would be the positive 1. And just like that, we have our factored form. Remember, we recognize factored form because we see things in parentheses, just like it is here. So the question is, all right, so why did we review factoring? Why did we do this again? Well, one of the reasons is we're going to learn a brand new form of a quadratic. Remember, to be a quadratic, it needs to have a power of 2, aka 2x is involved. Well, look, you may not see a power of 2 here. We did originally, but now we have 2x's split up, being multiplied. X times x will be that x squared. So this is yet another form of a quadratic equation, as long as there isn't a third x floating around. So let's talk about today's topic, which is intercept form. Now, when we're looking at intercept form, we also like to say that intercept form here is called factored form. So we have intercept form, aka factored form. And again, you have to be able to look at an equation and go, oh, it's vertex form, it's standard form, or it's intercept form. And intercept form is very recognizable because we literally see the parentheses. It's been factored. It's been broken down into two factors instead. Now, we've mentioned that vertex form instantly gives me the vertex. Standard form instantly gives me the y-intercept. So then, of course, intercept form must help me get something instantly as well. And here's what it is. Factored form instantly. So instantly gives x-intercepts. Again, that's why they call it intercept form. And so we see that here. Here's the little note about it. It says, because f of p equals 0, f of q equals 0, p and q are your x-intercepts. So they're letting me know that my x-intercepts, they're just giving it some random letter, are p and q. There they are. But they're also telling me that in order for me to find them, we just have to set these equal to 0. So that's going to be the big idea. I'm going to set each factor equal to 0. And then, of course, I'm going to solve it. But that's the idea. When I'm trying to find an x-intercept, well, it's already been factored for me. Then all I have to do is set each one equal to 0 and solve. Now, when I find my x-intercepts, well, we can see the P and the Q right here. Look, we have our x-intercepts. And of course, we call them x-intercepts because that's where it touches the x-axis. But then notice, once I find that instant information, which takes a little work this time, but once I find it, the next step is to go and find what they call the axis of symmetry. Now, the axis of symmetry is that line that divides the parabola in half. You want to think of it that way. So it cuts it right in half. And we know that the axis of symmetry is x equals whatever number we go through because it's a vertical line. Well, if you notice, they gave us a formula. It says x is equal to p plus q divided by 2. So just like last time, the axis of symmetry in standard form had its own formula. Well, this one does too. And if you're wondering, well, what do they mean by p and q? Remember, that's why you instantly found the x-intercepts so that you can find the axis of symmetry. So all you're going to do here is you're going to add your x-intercepts. Sorry, it's getting a little busy here with all this. You're going to add your x-intercepts, and then you're going to divide by 2. That's basically what we're being told here. But you see that formula is right here in the picture as well. But we also know that when it comes to the axis of symmetry hits a very special point right here, which we should all know the name of already, and that's the vertex. The vertex is probably the most important point that we find in a parabola. And so you see, we're still going to look for it. We've asked you to find the vertex for every problem we've done so far. Well, we're going to continue to do it again. And since you already have the x value, well, look, here's the reminder. We're going to do something we've already done. It says to find the vertex, all you have to do is plug in. Look, substitute the x value to find the y value. It's nothing new. We've done that already. As soon as you have the x from here, we plug it into the original equation, and then that's how we're going to find the y that goes with our vertex. And finally, the last thing on here is the idea of the parabola opening up, the parabola opening down. Well, we already know this. Look, it opens up if your a is greater than 0. It opens down if your a is less than 0. And we've already translated that before. It's going to open up. Right here it says if your a is positive. And of course, it's going to open down if your a is negative. Nothing new. We're just bringing back everything that we've talked about already when it comes to parabolas, but now we're just making sure that we understand how to handle intercept form. So intercept form has its own plan of attack, right? When it was standard form, I got the y-intercept right away, and then I started looking for the axis of symmetry. So this one's going to be a little bit different. All right, so here we go. Now, first thing I want to do when I'm working with these problems, right? They said, this is a quadratic. How do I know it's a quadratic? Because there's two x's that are being multiplied, but they've also already been factored. So how do I recognize factored form? Yes, it has two x's, but they're each in their own parentheses. They're being multiplied with each other. That's intercept form. So right away, I look at this number. My a is equal to 2. And so before I do any work, first thing I tell myself, if my a is a positive 2, then we're going to have a parabola that opens up. If I have a parabola that opens up, well then, we're going to have a min value. See, but I always start there. I want to give myself an idea of what it is that what my graph is going to look like later on. All right, but now we're going to go through the motions. They said, we want you to find the x-intercepts. Well, remember, your x-intercepts come from these two factors. I didn't highlight the 2 because there's no x there. We only look at the factors that actually have a variable for me to solve for. And so it says, make each factor, the x minus 5, the x minus 3, well, make them equal to 0. And look, with one little step, add the 5, add the 5, add the 3, add the 3. Just like that, x is equal to 5. This one is x is equal to 3. So officially, my x-intercepts that I'm going to be able to put on a graph are 5, 0, because we're writing it as a point, and 3, 0. So now we already have 2 points for my graph for later on. Now, what do I do with these numbers? Well, now I need an axis of symmetry. So it says, to find the axis of symmetry, use this formula. Again, all of this is in your word wall as well. So, use my axis of symmetry using that formula. It says P and Q. Well, there they are. P and Q are your x-intercepts, which we just found right now. So for my axis of symmetry, it says x is equal to fraction plus sign, a 2, and now it says bring me the P and the Q that you just found. So 5 plus 3. So we get 8 over 2. So of course we get an answer of 4. There's my axis of symmetry is x equals 4. Remember, we do need to attach a letter to it because we are drawing a vertical line. Now, I've got my axis of symmetry. So the next thing it says is, okay, now that you found that, we can use it to help us find the vertex. So right now, here's my vertex so far. We just found that the x is 4. All I'm missing is the y value. Well, it tells us to find the y value, all I have to do is plug in the x that I just found. So if I already know the x, all I have to do is find the y value by plugging back into my original equation. And you could call it t of x. You could just call it y. It doesn't matter. I'm just going to call it y for short. All I'm going to do is copy this up here. There's a 2. There's an x minus 5 and an x minus 3. But remember, when you're plugging in, you can let Desmos help you out, but you need to make sure that you don't leave anything out. So if you look carefully, you might say, yeah, you didn't write the x's. Well, of course I'm not going to write the x's. I'm going to plug in a 4 everywhere I see an x. Now I'm just going to do this very carefully on a calculator. So we do this calculation. We can let Desmos do it all, but we're going to get an answer that y is equal to negative 2. And that's not my final answer, of course, because I need to bring that in. Now I'm done with my vertex. My vertex is an official point that is considered 4, negative 2. We have the axis of symmetry. We've got x-intercepts. Now let's see what other questions they have for me. And yeah, look, these are all questions we've answered before. They said, is the vertex a maximum or a minimum? Well, don't forget, the A up here, we already said we were going to have a min. So I'm going to circle the word min. And the reason we said it was a minimum, it's not because it's a number 2, but it's the fact that it's positive. So because it's positive, that's my answer, because the A value is positive. Well, at this point, we're ready to draw this thing. So I'm going to move it up a little bit more so you can see the graph. All right, so first thing, x-intercept was 5 and 3. So 5, 0, 3, 0. The axis of symmetry was the line x equals 4. Well, look, it makes sense. The axis of symmetry should be right down the middle. That's why the 2 points are evenly spaced on either side. The other thing we had was the vertex. The vertex was the point 4, negative 2. So yes, it needs to be on here. But because it's 4, negative 2, that's down at the bottom. And now let's make sure, though. We said this parabola was going to open up. We said that up there on the top. And yeah, it is definitely going to open up. And so there we go. Remember, don't draw it going straight up. It does go forever to the left, goes forever to the right. The mistake people make is they say, oh, it goes up forever. Yeah, but it's slanted. So it goes up and to the left at the same time. It's going up and to the right, which is why, don't forget, my domain for a problem like this, for a parabola, is always all real numbers. That's never going to change because this graph exists, like we said, forever to the left on the x-axis, forever to the right on the x-axis as well. The range, on the other hand, that's the one that changes on us, because if you look at the range, first of all, it opens up. So right away, I'm going to say y is greater than And of course, we say equal to because there is a dot right at that little minimum. But again, range, y is greater because it's going up forever. What's the lowest y that we get? Well, remember that goes back to your vertex. Your vertex was the 0.4, -2. Well, then the lowest that we go is -2. And that's how we handle the range. Our range is always handled by looking at the vertex and seeing, hey, that's the lowest we go. All right. So there's the plan of attack for intercept form. We're going to try one more here, of course, right next to it. So let's give this a try. Let's give it a look. Okay. Now, again, looking at it carefully, I'm going to look at this number first. I want to know what I'm going to draw. And yeah, we know it's a parabola. We know there's two x's multiplied, so that's x squared. But it's that a value. That a value gives us a lot of information. So when I look at that a value is a -2. So in my head, I'm already imagining a parabola that's doing this. So we know it's going to open down, which means it's going to have a max value at some point. And again, they didn't ask us to do that. But when you give yourself that drawing, it makes sense. When you get to the end, it'll make sense. If your points look right, you know, okay, I'm on the right track. So now we have this part. So of course, this is the factored form. That's how I recognize intercept form. It's got the parentheses. That's the easiest way to spot it. And so I'm going to look for my x-intercepts. So that's step one. So I'm going to make x plus 3 equal to 0 and x minus 1 equal to 0. And again, if you didn't catch it early on, the reason we don't make the -2 equal to 0 is because it doesn't have an x. Only factors with an x are set equal to 0. All right, little math here. Subtract the 3, add the 1. And so we get x is equal to -3, x is equal to +1. And just like that, my x-intercepts are officially -3, 0, because the y value is always 0, and 1, 0. All right, so we got our x-intercepts. But now they want me to find the axis of symmetry, the line that goes right down the middle. So here's my formula. It says P and Q. Well, there they are. These are the two numbers that I'm supposed to use in this formula. That's why we have to find them first. So x is equal to -3 plus 1, and then I'll divide it by 2. -3 plus 1 is -2 over 2 is just -1. So we have our axis of symmetry, which is x equals -1. Yes, don't forget to attach a letter because it is a vertical line that we're talking about. So then that brings me to the vertex. Well, again, you already have part of it. See, for my vertex, it's a point. And we already know the axis of symmetry goes right through the vertex. So I get to put that -1 that we just found into my vertex. The only thing I need is a y value that goes with it. See, over here, we did the same. We found the x, so we put it right in our vertex over here. We do the same thing there. So I'm going to copy my equation very carefully. I know it's called f of x, but for short, I'm just going to call it y. I'm just copying it down from the top. There it is. So I copy it down one more time, but this time, if I see an x, I'm going to leave it empty. There's an x. I'm just making sure I don't leave anything out. And I'm going to plug in that -1 that we found earlier. And of course, please let the calculator help you. This is where we want to avoid any little mistake that may come up. And if you do it correctly with decimals, your y is equal to 8. And once you have that y, don't forget, that's not something I'm going to plug in or graph. I'm going to bring that back over here. And now we have our vertex. Now we know where this parabola is going to make that turn. All right, only thing left is actually start drawing this thing. And don't forget what we said earlier. My a is a -2, which means it opens down. We have a max, and that's my reason for number 4. Number 4 says my vertex is a max or a min. Well, we already called it earlier. We already said a max. And my reason for saying it's a max is because the a is negative. That's the reason we made that decision early on in the problem. All right, so I'm ready to draw everything. Look, my x-intercept is -3. There it is. X equals 1. There it is. My axis of symmetry is x equals -1. Well, yeah, it makes sense. Look at that. It has to be right down the middle. So remember, if it's not right down the middle, then something went wrong somewhere. But it should be evenly spaced on both sides. We also know that the vertex is -1, +8. So there's 7. So we're off the grid by a little bit, not too much. There's the number 8. And so we said early that it was going to be a parabola that opens down. And so there it is. We have a parabola that opens down, and we should be naming it. That's where I messed up earlier. We should be calling it f of x. I think this one over here was t of x, but we should be naming our parabola. All right, last two. It says, tell me the domain. Well, it goes forever to the left and down. It goes forever to the right and down, of course. But that idea of left and right forever means all real numbers. The range is the only one we have to be careful with. My range has to do with the letter y, so I instantly write my y. But then this one heads down. It opens down and goes down forever. So that's why we're going to say is less than or equal to, because it heads down forever. But what's the highest that it went? Well, that's where the +8 kicks in. Remember, it comes from the vertex, so my y is less than or equal to the number 8. Again, every form has its own plan of attack. So that's what we're seeing here. Now, we're going to pause the video at this time, and we're going to pause the video. You're going to get about 10 minutes to work on the U-tries. So we're going to have the U-tries here. Please double check your answers with the U-tries first, so you can see and make sure that you're doing these correctly. But test your skills. See if you understood the concept and help each other out. All right, so let's pause the video now. Okay, so at this point, you should have already tried the U-tries on page 14 and checked your answers. So now let's look at page 15. This is the last part of today's notes, and it's all about finding x-intercepts and y-intercepts. And so it says, if you're going to look for a y-intercept, well, remember, if I'm looking for a y-intercept, I don't want the letter x to be anywhere. So the easiest thing is substitute a 0 for that x and it completely disappears. But it's also that when you draw a y-intercept, your point, don't forget, for a y-intercept, as a point, your x is always 0. That's why we plug in a 0 for that x. Same thing for the x-intercept, by the way. If you're looking for an x-intercept, well, we also plug in a 0, but for the y, we want the y to completely disappear. And because anything that's on the x-axis has a point where it's some number, but then the y value is always 0. So that's why we do a little substitution. Now, remember, it depends on what kind of equation you get. If you get standard form, remember, standard form instantly gives us the y-intercept, and the y-intercept would be right here. So standard form, instant info right here. That's the instant info that we get. And then, of course, there's the 0, right? The 0c, just like we said when you write a point, but the c value is your y-intercept. Only in standard form, though, nothing else. Now, when I'm looking at intercept form does not give me a y-intercept right away, but it definitely gives me x-intercepts, and they come from these factors. Just remember, you have to set it equal to 0, but that's the instant info we get. So every form gives you one piece of information very quickly. Standard form only gives me a y-intercept. Intercept form only gives me the x-intercepts. So that's why it tells us down here at the bottom, if you are finding x-intercepts from standard form. Remember, standard form only gives you instant y-intercept, nothing else. So how do you find the x-intercepts from that one? Well, that's where we bring everything we've learned. Look, you factor it. Remember, make sure you look for GCF, because when you factor it, you're going to end up with something that looks like this. X plus P times x plus Q, kind of like it does over here. Then you're going to substitute 0 for the y. What they're really telling me there is make each factor, right? Make each one of these. Make each factor equal to 0. And then, of course, solve. But that's what they mean by the zero product property. That's basically where we make each factor equal to 0. So we just want to find the x-intercepts. So here we have 2 more problems for the day or for the week. So here we go. Now, they want me to find the x-intercept and the y-intercept. Now, keep in mind, I see 2 x's. I don't see parentheses. That means this is standard form. And if this is standard form, then right then and there, there's my y-intercept. So I'm not going to waste my time here. I'm going to write that in right away. And look, I already gave one of my answers. Standard form instantly gives me that information. So we put it in. There, that part is done. But now they also said x-intercepts. Well, remember, this is standard form. This is not intercept form. So what I need to do is I need to factor all of this. So now I'm going to factor. All right, so I'm going to bring in everything we've learned before. I'll write my f of x, of course. And if I'm going to factor, well, the first thing I'm going to do is I'm going to check it for a GCF. So let's see. There's a number, there's a number. That's an invisible 1. So right away, no GCF to worry about. But we always check. We always have to double check. No GCF means, then let's go right into parentheses. This is where guess and check starts. It says x squared. Well, that's the easy part. We split up the x. There's no number in front of the x besides a 1, so that makes this problem even easier. Now, I do have a positive. Well, the only way to multiply to get a positive is positive times positive or negative times negative. Well, here's who's calling the shots. Remember, whatever math I do later on combining, I need to get that negative 11. So if my options are a positive and a positive, that's not going to work. But if I multiply 2 negatives to get a positive, that will add up to a negative value. So now I already know my answer is going to be 2 negatives. So we get that in there now too. All right, let's think it through. I need all my multiples of 18. 1 times 18, 2 times 9, 3 times 6, and that's about it. Both of these numbers are going to be negative, right? They're all negative, but I want to combine them so that I get a negative 11x. So the only 2 numbers that I can combine to get an 11 is right here. One of them has to be a negative 2. The other one has to be a negative 9 because negative 2x plus negative 9x gives me that negative 11. Remember, factoring is something we have to keep working on. But there, I'm done factoring. And now that I'm done factoring, according to the step, I'm supposed to make this equal to 0 officially. That's where we're letting people know that we're going to be looking for x-intercepts. And then you make each one equal to 0 now. And so basic steps here, right? Add the 2, add the 9 on this one. So x is equal to 2, x is equal to 9, and just like that, I'm ready to come over here and write down my answer 2, 0, and 9, 0. So there's my 2 x-intercepts. My y-intercept we found a long time ago, but there it is. That's why we've been factoring. That's why we've been talking about factoring, so that we can turn standard form into intercept form in case I need to find x-intercepts. That's the only way to go with that. So let's try one more. You have some U tries at the bottom. All right, last problem. But first things first. This is standard form. How do I know? I've got 2 x's with no parentheses, which means if this is standard form, there it is. We have officially found our y-intercept. Remember, it is given to us instantly. So I'm going to go down here and write it. My y-intercept is 0, not a 6, but a negative 6. All right, y-intercept is done. So now I'm going to factor this one. So when I'm looking at this, I have this number, this number, this number, 3 numbers. So I'm going to ask about a GCF. And the only number that divides all 3 of them, well, it's the number 3. So remember, officially, this is what I'm thinking. I'm thinking about dividing. But here's the actual work. F of x is equal to my GCF. You don't just divide. You have to make sure that 3 is part of the problem still. Divide everything by 3 now. So then, 3 divided by 3 is 1x squared. 3 divided by 3 is 1x. Negative 6 divided by 3 is negative 2. And we close our parentheses. Now, we're not done factoring, but I'm done with the GCF portion. Remember, that 3 is out there from now on. So f of x is equal to 3. But remember, this is now where we break it up into 2 parentheses. It says x squared, so I go x and x. We split that up. And now we're going to think about it. I'm trying to get a 2, right? We're trying to get this 2 right here using multiplication. So this is where we look first. And if I'm trying to get a 2, the only numbers that multiply to give me a 2 are 1 times 2. It's my only option. Now, it is a negative. So that means one of these numbers has to be a negative. So one's negative, one's positive. All right, but now think about it. I want to make sure, now that's when I look at the middle. I want to make sure that I get a positive 1 as a result. One's positive, one's negative, but I want to stay positive as my result. So that means the only way this is going to work is if you have 1x and 2x, the only way to get a positive x is if this is the negative and the 2 remains positive. That's the only way to remain with that positive 1x. So then it's negative 1 and positive 2. All right, we're about to finish here. We're going to make our f of x equal to 0. Yeah, you still keep writing that 3. X plus 2. But now that we've done that, we make the factors that have an x. This does not have an x, so I don't mess with that. Equals 0. X plus 2 equals 0. And I'm out of space, but look, you're going to subtract the 1. So negative 1. Right here, you're going to subtract the 2. So negative 2. And just like that, our x-intercept is negative 1 comma 0. And of course, negative 2 comma 0. You have to keep working on that factoring. You need to become an expert at it because we are going to be factoring from now on, basically up until the end of the school year when summer's coming around. So factoring is big in this class. You have to make sure you keep practicing to get better at it. All right, so with that said, do the 2 U-tries here at the bottom. Once you do those, give it a quick check, and then jump into today's assignment. Use the rest of the time to catch up on any missing work. But most importantly, just make sure that everything is done for this homework assignment. Don't forget, it's on BIM. Even though you have a paper, you're going to submit your answers on BIM as well. All right, everybody. With that said, have a wonderful day. Enjoy your weekend, and then I'll see you next week.